Hello, everyone. My name is Sasha Loewen. I am a PhD candidate at Montana State University. And today I'm going to be telling you about my project, which involves precision organic agriculture. So I'll get right into the research question here. We want to know whether we can use seeding rates to apply precision agriculture technologies in organic grain systems. So this involves optimizing green manure seeding rates, but also attempting to find maximized net returns based on seeding rates. And then, of course, because these are organic systems, attempting to find new ways to manage weeds using these technologies. So the method that we use in our lab group involves something called on-farm precision experimentation. This is a methodology where we find an input for the farmer that they want to optimize for their field and randomize it across the field to understand the variation across that field such that we can find optimized rates for that input. So with me, I am working with organic farmers, and so our primary input of interest is seeding rates. So we begin with a prescription map, which is randomized seeding rates across an entire field. We then collect as much information as we can about that field so we can understand the spatial variation present on that field, which includes remotely sensed data from satellites, drones, and so on. We then get the information off of the farm equipment, including the as-applied map from the seeder, the yield information from the combine. We then put all of those variables into our analysis. The examples I'm showing today use random forest analysis and come up with a new optimized map based on all of this data such that we can find a prescription map that is optimized for that seeding rate such that the net return is maximized for the farmer. So that new optimized seeding rate then goes into the following season that farmer plants that crop. And we now have a new optimized rate that we have for the farmer. But additionally to that, we don't just put in the optimized rate, but we continue experimentation within that field. So we include experimental strips alongside the optimized strips so that we can understand the field both spatially, but also temporally, understanding that a lot of the variation comes from multiple seasons. So a number of the farmers that we're working with are in Montana, but also back where I'm from in Manitoba, we work with a farmer there. And so I'll just show you a couple examples, quick examples of what we're doing with the farmers. So this is a field. This is an 80-acre field where the farmer has planted a green manure cover crop, which of course a green manure cover crop for an organic farmer in particular is a crop that fixes nitrogen naturally from the air such that it is present in the soil for the following season's cash crop. So this farmer planted peas as their green manure crop in 2020. They varied the rates of the peas across the field. They then planted a uniform rate of wheat in 2021 and harvested it to determine what the effect of the varied rate of pea had on the following season's wheat crop. So this is what the experiment looked like. You can see these topographic variables here, which often play a big role in determining the spatial variability for the field. This is what actually happened. So in 2020, the farmer planted varied rates of pea. You can see these varied rates across the entire field. And then in 2021, they harvested the following season's wheat crop to determine what effect that pea seeding rate would have on the wheat crop. Our initial hypothesis being that higher rates of pea would be able to fix more nitrogen and thus create a higher yield in those spaces. And what we actually saw, if I highlight in red here, you can see an example where the dark purple is the highest pea seeding rate. And you can actually see in that area generally a lower wheat yield. And so a different driver might actually be in play. And what we thought, especially after having conversations with a farmer, is that the higher pea seeding rates are actually using up more moisture, thus preventing a higher wheat yield in the following season. So anyway, all of that goes into our model then, of course, and we come up with a new optimized pea seeding rate, one that would maximize the net return and the wheat yield for the farmer in the following season. And it's interesting to look at that predicted optimized pea seeding rate, and you can see how it follows some of the topographic variables in determining where the pea seeding rate should be higher, and likely follows areas that might be collecting more water or other such variables. But it's very interesting then to take this to the farmer and have those conversations and say, okay, what are the variables that you see at play, and what can we start to learn from putting together all of these remotely sensed sources and this experimental data to really start to understand some of those drivers and help the farmer put in the best varied input rates that they can across the field. So I don't have time to go into this slide in detail, but I just wanted to highlight that this project is also looking at weed management. And so we can do what I just showed you earlier, except instead of optimizing for net return, we can optimize for minimized weed pressure. And so as we start to automate this workflow, we can really start to look at different ways to help organic farmers deploy these modern technologies. So just to summarize, precision organic agriculture, this is developing a methodology where we are employing modern technology on organic farms to help them maximize the net returns, deal with their critical issues such as weed management. And moving forward, our group is going to continue working with these 5 farmers to optimize their fields over both space and time, automate this workflow so that it's easier for the farmer to use. And we're in the process of developing an open source software application that ties all of these things together. So with that, I just want to say thank you to my lab mates and collaborators, and please feel free to email me. Thank you.